Hello and welcome to this video. This is part 2 of a multi-part series all about vector search indexes and RAG, Retrieval-Augmented Generation, within the Databricks ecosystem. If you have not watched my first video, please do. That video is all about setting up a vector search index on a table that we will be using in this video. We will be taking the results from the vector search index and using them as context when asking questions to a large language model. For a very quick refresher, I'm going to go back to the notebook that we used in the first video, and I will show you the table that we are using, which is this demo product text table. You can see the data that we have in here is just product information about shoes. So we have the product ID, the product name, and a text describing the product. If you go down here, you can see the queries that we ran against the vector search index that we created on that table. The index was created against the text field. And so right here, we ran this query. We said shoes for gym training, and we told it to give us back the top 5 results. So for this video, we are going to take these results and use them as context when asking a question about the products to a large language model. So if we go back to our other notebook, I will show you how this is all set up. I want to emphasize this is not a deep dive into the technical aspects of the code or about RAG. This is simply showing you how to set this up in Databricks. So first you're going to want to install some necessary libraries, which I did right here. You can see Databricks SDK and Databricks Vector Search. Okay, we'll keep scrolling down. Next, we want to initialize some variables. We have a workspace client, a vector search client, all the necessary libraries. We also initialize a variable called index, which takes our vector search index that we created in the previous video. If you already know how to create vector search indexes and you have your own, you can simply replace this with your vector search index. So I'm going to run that and keep going. So the next few cells are a series of functions that are all going to be tied in together into a final function that kind of serves as the RAG pipeline. So this function right here is simply the similarity search against the vector search index, returning the top 5 results. You can see here that I run it at the end just to print out the results, but where we're actually going to be using it is down at the end of the code. Right here is what formats the context. This is a function that formats our context. So it's going to take the results from the function above and format them nicely so they can get plugged into the LLM. And you can kind of see what the format looks like. Down here is where we actually build the prompt. So we do take the context that we built in the function above, and then we add some instructions for the system. This will be saved as the system prompt. We add the user prompt. We have the question that will be passed in as a parameter to the function, and then we tell it, here are the retrieved products from the catalog, and we instruct the LLM to only use that information and provide the best possible answer. This function will return both the system prompt and the user prompt. And again, you can see here below that I've printed the return values just to kind of see what that looks like. We have the system prompt and the user prompt. We keep scrolling down. This is our run LLM function, which will serve as the final function in our pipeline. It kind of it brings together the system prompt and the user prompt and adds them to this messages variable, which has to be formatted in this specific way. One thing I forgot to mention is that we are using this llama instruct model, and depending on the model endpoint that you are using, this messages variable will need to be formatted differently, or maybe it'll be named something else. And then you can see that it returns the answer, and I ran a quick little test run. And then down here we have our final function, which kind of brings everything into all the functions together into a simple pipeline. So we retrieve the products, that's that similarity search, save it as rows, and we format the context by plugging in the rows retrieved, saving that as context, which is then plugged into the prompt building function that has both the query and the context, and then we get our answer by running the run LLM function and plugging in our system prompt and our user prompt. And then we go down here and we actually run the function. So we save our query in a variable and we run the function by plugging in that query. So I'm going to run it and ask it, what are the best shoes for running? And there you go. It says the best shoes for running are these two. Gives a description. And it says basically they're specifically designed for running, which makes them the most suitable options. Let's ask one more question. Let's say, what are the most comfortable shoes? And let's see what it says. The Comfort Walk Pro shoes are described as comfortable walking shoes and feature memory foam insoles. So there you go. This is what the model, based on the context, decided are the most comfortable shoes in the catalog. And there you have it. That is how you take a vector search index, search results, and use them as context when asking a question to an LLM to create a RAG-powered solution in Databricks. Be sure to check out my next video where I show you how to take this notebook and this code and plug it into a Databricks app where you can create your very own chatbot with a nice interface. Thank you for watching. Please don't forget to like and subscribe.